Alright. Here's our AP level centripetal force problems from last week. Beginning of the packet looks like this, but the questions that I got the most comments on were 9, 10, and 11. Alright, so we're going to take a look at number 10 right now. Alright, so this one you're still dealing with a horizontal loop. Riders in a carnival ride stand with their backs against the wall of a circular room of diameter 8 meters. The room is spinning horizontally about an axis through its center at a rate of 45 revolutions per minute when the floor drops so that it no longer provides any support for the riders. What is the minimum coefficient of static friction between the wall and the rider required so that the rider does not slide down the wall? Alright, so we got to figure out what is your coefficient of static friction that's needed in order to keep the rider attached to the wall of this spinning amusement park ride. Alright, so based off of the description, I'm going to draw a little picture just to make it easier to understand. Alright, so this ride is a big rotating cylinder. Right, and it spins around, and then your person right there is stuck to the side of the wall. Alright, so the ride spins around. They're pushed outwards. If the wall wasn't there, the person would want to go in a line tangent to the circle, but because there is a wall, they're supported. The wall is constantly pushing inwards. Right, it's always pushing in and keeping this person within the circle. Alright, so the wall is pushing inwards towards the center of the circle that's perpendicular to the wall. Alright, so the force that's causing this is going to be your normal force. Right, but in this case, normal force is what's causing the circular motion of the person. Right, remember that centripetal force is always caused by another force. Right? And in this case, normal force is the net total force acting towards the center of the circle, and that's what keeps the person in line with the circular motion. Right? That normal force wasn't there, they go through the wall, they go flying in a line tangent to the circle itself. But the question itself, the question is asking about the static friction on the wall. Right? So that's not really related to centripetal force itself. Right? Centripetal force is going in towards the center of the circle, and then your friction is actually pushing upwards here. Right? That's going to be static friction, and it's going against gravity. Okay, so if we're looking for static friction, coefficient of static friction, how does that involve with centripetal force? We're going to make a whole bunch of leaps, right? If we can calculate the centripetal force, then we'll know the value of the normal force, and then you have to remember that the equation for friction is based off of the amount of normal force that's being applied, right? So whether you're dealing with static or kinetic, in this case we're dealing with static friction. Right? If we can calculate the normal force, right, or in this case the centripetal force, then we can use that information to figure out what our coefficient of friction is. But then we'd also need to know the force of gravity. Right? But there's some more information that's given, force of friction. I just gave it away. Right? We need to figure out the force of friction, but because of this diagram, or the way that the person is pressed against the wall, we know that gravity has to be equal to friction. Right? If they're stationary against the wall, they're not sliding up or down, we know that our forces, the sum of our forces in the y direction, have to be equal to 0. Right? Well, a vertical force is friction. Friction goes up against gravity. Right? And gravity is pulling downwards. So we know that they balance each other out, so they have to be equal. Equation for gravity is mass times 10, right? Or mass times acceleration due to gravity. We use 10. It's based off of mass, right? So we can't calculate friction unless we know the mass. But they don't give you any masses in this problem, right? So when I see an AP level problem like this, when I see a problem and I am relying on this information here, right? I know that I need to know the force of gravity in order to calculate friction, right? But there's not enough info to actually get gravity itself. So I'm just going to leave this. Right? I'll leave it equal to m times g for now, because the only reason they would ever give you a problem that's set up like this is if the masses were going to cancel out later on. Right? That's the only reason why they would give you a problem like that with no mass. Alright, so we'll just leave that for now. Right? Force of friction has to be equal to mass times acceleration due to gravity. Right? And that's going to get substituted in here later on. So what else? Right? There's a lot going on in this problem. We just looked at the vertical forces, friction and gravity. But this is still basically a centripetal force problem, right? So we have to come back to this. Well, our equation for centripetal force is based off of tangential speed, but they don't give that to us either in this problem. They do give us the frequency of the rotation, right? It spins about its axis at a rate of 45 revolutions per minute. Right, so that's a measure of frequency, right? And it's kind of useful, but we need that in a measure of how long it takes to do one rotation. Right, so if this is 45 revolutions per minute, let's get rid of the minutes first. Right, let's figure out how long it takes to do a rotation in 1 second, or how many, yeah. So then your minutes goes up top. We have 60 seconds in the bottom, right? So it's just 45 divided by 60, and we get, right, still a frequency, 0.75 revolutions per second. All right, we want period, which is seconds per revolution, right? So then that's just going to be 1 over our frequency, which is 1 over 0.75 revolutions per second, right? So if we did flip that, if we take the inverse of this, we would get seconds per revolution. So then that means that this is 1.33 seconds, right? And that's our period. Time that it takes to do 1 revolution around the circle. Alright, so we have our period. Then that can be plugged into our equation for tangential speed. Vt is equal to 2 pi r over capital T. Right? They did give us the radius for this problem. They said, right back at the beginning, they said their diameter was 8 meters. So that means that our radius has to be 4. Right? 2 times pi times 4 over 1.33. So we solve all of that. 2 times pi times 4 divided by 1.33, and we get just about 18. We'll go at 18.9 meters per second for your tangential speed. Alright, so that's how fast this person is rotating around the outside of the circle. Alright, so our tangential speed is 18.9 meters per second. So the next thing to do with that would be to plug it into our centripetal force. Right? Centripetal force is what's going to help this all come together at the end. So Fc is equal to mvt squared over r. We don't know the mass, right? One wasn't given to us, but that's okay. This is the second mass. Here's the first one that we saw. Eventually, these two are going to cancel each other out. All right, we just calculated dt, and our radius we know is 4 meters. All right, so FC is going to be m times 18.9 squared all over 4. So I'm going to do all this, and I'm going to leave it in terms of m. All right, and we're going to do 18.9 squared and divide that by 4, and you get just about 89.3. Alright, that's 89.3 m, the mass, not 89.3 meters. Alright, maybe I should have just done a capital M for both of these since it's unknown. Alright, but just remember this is mass, not meter. So now we have our centripetal force. And now we're going to do a whole bunch of substitution, and everything's going to fall together right now. Alright, so let's see here. Force of friction, right? Friction is equal to m times g, and it's also equal to mu times normal force. Right, so right here, friction is equal to Fg, right, and then it's also mu times Fn is equal to m times g. Well, our normal force is equal to a centripetal force, and we just calculated that to be 89.3 meters. All right, so this is going to be mu times 89.3 m. Oh, I just said it's 89.3 times the mass, not meters. Duh. So it's mu times 89.3 m. And then we have g over here, and that's just going to be 10. Alright, so right here, I told you, I promised you, two masses, they're going to cancel each other out. And then we know that g is equal to 10. So then this becomes mu times 89.3 is equal to 10. Right, so then you would just do 10 over 89.3. You get 0.1119, and we'll just leave that as 0.11. Right? And you compare that to your answer choices. Look at that right here, 0.11. Right, so that's your correct answer for this one right here. Cool? Cool. Alright, there you go. That's number 10.